All right, you guys, this is a problem from homework 63, and this is problem number 10. Okay, so here we have a regular square pyramid is inscribed in a right cone of the same height. The radius of the base and the height of the cone are each 10 centimeters. What is the ratio of the volume of the pyramid to the volume of the cone? So what it's asking us for is we're looking at volume of the pyramid to volume of the cone. So that's the ratio that it's talking about. So again, we have a pyramid inside of a cone. So if I want to visualize this, I'm going to start by drawing my pyramid. So when I draw a pyramid, I start by kind of giving that square base a little slant to it, just so I can draw it in 3D a little bit better. So here is my base shape. It's meant to be a square. So right here would be its apex, and I'm going to connect here to draw in all of those lateral edges just like so. Okay, so there is my pyramid. Okay, my regular square pyramid is inscribed inside of a cone. Okay, so I have a pyramid right inside of a cone. Okay, so let me draw a circular base around this square. Just like that. So I'm picturing that, and then here, all of these points here would connect just like so. So what's going to help me out is if I can picture what the base looks like. So if I picture my base right now, I have this square right here, and then I have the circle around it like that. Okay. So what it's telling me then is that the radius of the base and the height of the cone are 10 centimeters. So if I draw in my height right here, there's my height in green, that is 10 centimeters. And then I know that my radius here, radius of the base is 10. So if I connect center to any point on the circle, that's 10. So I'm going to draw it in right here and mark that as 10. Okay, so I know the radius for the circle, so I can figure out my cone's volume first. So if I look at my volume of the cone, I'm going to do that first because I have the information I need right now. Okay, my volume is 1/3 base area times the height. And since it's a circle, I can call it a pi r squared. So 1/3 pi r squared times the height. So I'm plugging in a radius of 10 and a height of 10. So I'm taking 1/3 of 100 times 10. So really 1/3 of 1,000. So I could write that as 1,000 over 3 and then pi and centimeters cubed. Okay, so that's what I know right now. I know the volume of my cone. My pyramid, well, I need to figure out how to get to my base area. So I know that this is a square. So this shape is a square. So there's a couple ways I could go about it. I know that for any square, I could do base times height. I could do 1/2 the apothem times the perimeter, or I could go through the diagonals. So I could do 1/2 diagonal 1 times diagonal 2. I think that's going to be easiest. So as I focus on my square, area is 1/2 diagonal 1 times diagonal 2. So if I draw in another radius, that would be 10, and then the whole diagonal would be 20. So what I'm plugging in here then is 1/2 of 20 times 20. So half of 20 is 10. 10 times 20 is 200 centimeters squared. Okay, so that is the base for my pyramid. So let's get the volume of the pyramid. So a pyramid would be 1/3 base area times the height. So I'm looking at 1/3. My base area is 200. The height of it is 10. So here I'm taking 1/3 of 2,000. So I have 2,000 over 3. That's the volume of my pyramid. So I have the two pieces that I need. Now I just need to figure out how do I write that as a ratio. So pyramid to cone. So my pyramid, right, is 2,000 over 3 over the cone, 1,000 over 3, and then the pi. So I've written it as a complex fraction. I have a fraction over a fraction like that. So it's easier to visualize this as 2,000 thirds divided by 1,000 pi thirds like that. So then make it a multiplication problem. So 2,000 thirds times, I'm going to flip this, 3 over 1,000 pi. So now I know that when I'm multiplying fractions, I can reduce top down or on my diagonals. So the 3 and the 3 go to 1 and 1. The 2,000 and the 1,000 go to 2 and 1. So what I'm going to end up with is 2 over pi. And that is my ratio when I have a pyramid inscribed in a right cone, right? Their heights were the same, and we knew that the radius of the base and the height of the cone were 10 centimeters. I hope that helps. I keyed it on my homework a different way, so I'm trying to show you another option that just makes it a little bit easier. All right, have a good rest of your day.